Okay, so here we go. New section, new chapter, chapter 2. Chapter 2, we talk about trigonometry. Trigonometry is a fancy way to say triangle measurement. So different measurements of different parts of a triangle. Specifically, the trigonometry that we are going to look at for chapter 2 is right angle trigonometry. And right angle trigonometry, as the name implies, deals with triangles that have a right angle in it. So if you remember that from back when you've talked about that before, this little indication of a indication with the box here indicates that this is a right triangle. Okay? So you can be told that by saying by having that box be shown. You can be told that by them telling you, or the question telling you, that it is a 90-degree angle. You can be told that by doing other calculations or looking at the triangle itself. A couple of things that we need to remember with right angle trigonometry, specifically right angle triangles, is that if we have a right angle triangle, one calculation that you should know of and be aware of already is this one. Oh, what do I keep doing here? What's going on? Oh, I know that. I'm way up in the title bar. Let's start here. So we've used Pythagoras a little bit already, so you should be aware of that calculation. One other thing that you should also be aware of with right angle triangles is that if we have a right angle triangle that looks like this, whoops, that's an ugly line. And the ratios of the sides form these ratios, then we will have a right angle triangle. It will be a right angle triangle. This is called the 3, 4, 5 triangle. So any triangle that has a ratio of sides similar to this will be a right angle triangle. Okay? So there's a number of different things that can be told to you in some way, shape, or form to tell you that you're dealing with a right angle triangle. Be told the angle, whoops, be told be told the angle, be shown the angle. You could have calculations that prove this, as well as you could have a triangle in ratio form 3, 4, 5. Okay. Trigonometry is used to calculate lengths and angle measurements of the triangle, provided you're given enough measurement. And with all of this, it all depends and is based on the properties of similar triangles. Now, we don't have to worry about how we come up with these calculations or formulas that we're going to use. We just need to know how to use them. Okay. So there are 3 specific ratios that we are going to look at in chapter 2. Okay. The 3 primary trig ratios, trigonometric ratios they're called. One is the tangent ratio, the one is the sine ratio, and one is the cosine ratio. Now, once we learn one of these, and we're going to look at the tangent ratio first, once we learn one of these ratios, the calculations and the steps to perform the calculations are the same for the other 2. It's just a matter of using a different button and a different ratio, but all the steps and calculations are the same. So it's important to get a handle on this right away so that you can apply that idea to the next 2 ratios, sine ratio and cosine ratio. So here we have this statement. It says, if angle A is an acute angle, and you should know or have an idea that an acute angle is an angle that measures less than 90 degrees. So if angle A is an acute angle in a right triangle, then, and of course we know that a right triangle has one angle that measures 90 degrees, then we have these 3 ratios. Tangent of angle A is the length side opposite angle A over the length of the side adjacent to angle A. Sine A is the length opposite to angle A over the length of the hypotenuse. and cosine A is the length of the adjacent to angle A over the length of the hypotenuse. So we have three different ratios, three different trig ratios, okay? But once we learn the steps for one, we'll know them for all. Now these ratios get abbreviated and are on your formula sheet. They get abbreviated to something that looks like this. Tangent of angle is equal to opposite over adjacent. Okay, I believe that's how it's typed up and written on your formula sheet. The sine of an angle, now in this case we're talking about angle A, but this is what's showing on your formula sheet. Okay, the sine of an angle is equal to opposite over hypotenuse, and the cosine of an angle, oh, I don't want that, I want theta. Oh, theta, I didn't tell you what theta was, is equal to adjacent, or not, adjacent over hypotenuse. Okay. Now, just a quick step back here, because I realize you probably haven't seen this before. This is a fancy symbol. This symbol is a fancy circle with a line through it. Okay. This is called theta, Greek symbol. Oops, I could spell that so you could read it. Theta, and it's a standard symbol that's used to represent some kind of angle or some angle. So here in our ratio, tangent theta, some angle, is equal to opposite over adjacent. That's the ratio of the side lengths. Now, you have to remember how to use these. Yes, they are on your data sheet, but a nice simple little acronym that can be used to help you remember is this one here, SOHCAHTOA. And I will say this, and you'll see me and hear me say this like so many times that you won't want to hear me say it again. So this simple acronym, SOHCAHTOA, SOHCAHTOA, is a simple acronym that tells us what each trig ratio is. Okay, so if I can bear with me here, if we look at SOH, this is sine is equal to opposite over hypotenuse. Opposite over hypotenuse. Cosine of an angle is equal to adjacent over hypotenuse. Adjacent over hypotenuse. And of course, now that we've seen that a couple of times, tangent of an angle is equal to opposite over adjacent. Opposite over adjacent. Okay, so it's just a simple little trig ratio that helps you remember what the ratios are. Now, before we can even start talking about how to use these ratios, we have to understand how to label our triangle. And our triangle labels all depend on what angle we're using as the angle in question. Because we have three different angles in our triangle. One of them will always be the right angle. One of them will always be the right angle. The other two are two other angles, but in order to use these trig ratios, we obviously need to know what the hypotenuse is, what the opposite side is, and what the adjacent side is. Okay? The hypotenuse is always the longest side. Should know that already. It's always opposite to the 90-degree angle. Okay? So this one here, I'm going to change my colors just because I already used purple there. This one here, this is the hypotenuse in this triangle. Okay. Now, before we can even decide what is the adjacent side and the opposite side, we have to say, or we have to have some kind of angle to refer to. So let's say we're talking about or asking questions about this angle here. If we're looking at this angle, then the angle or the side opposite to that angle in question is the opposite side. So we know the hypotenuse is opposite to the 90-degree angle. We know that the side opposite to the angle in question is the opposite side. So that leaves the angle beside, or the side beside the angle we're talking about, being the adjacent. And adjacent is just a fancy word meaning beside. Okay, so let's whip through a few practice ones here. So here's your right angle triangle. It's right angle because I tell you it's a right angle triangle. That means this side here is our hypotenuse. Notice the pause there, just so you can write it in. Now we can't label adjacent or opposite yet because I don't know what angle we're talking about. So let's say we're talking about or asking questions about this angle. That means that this side is my opposite side and this side is my adjacent side. All right, a couple more. Here's our right angle triangle. If this is our right angle triangle, then I know that this side is the hypotenuse. If this is the angle we're talking about, then this side is the opposite side. It's opposite to the angle we're talking about, and this side is the adjacent side. Last one for you to do. I'll give you a few seconds. There's our right angle triangle. Label it with the hypotenuse, opposite, and adjacent. Do 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 do. Okay, here we go. This side, opposite to our 90-degree angle, longest side of the triangle is our hypotenuse. Oh, you're stuck because you didn't know what angle to use. Let's use this one. I'll give you another couple seconds. 3, 2, 1. If that's our angle, this is our opposite side. This is our adjacent side. Now, if for whatever reason the question says, well, there's that calculation or that setup for that angle in that triangle, and now we need to look at this angle, then our labels change. Okay, and I'll keep it in red here so you can see how they change. Our hypotenuse stays the same. It will be the same for both sets. This side now, though, becomes our opposite side. This side becomes our adjacent side. Oops, that should be a J. Okay, so the labels change depending on what angle you're looking at in the triangle. So you have to be very careful because your calculations, all your ratios are set up and revolving around how you label your triangles with reference to the angle you're talking about. Tangent is opposite over adjacent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Okay, so you really have to understand those labeling of the triangles. I'll come back in the next video and show you how we can start using those ratios in calculations and the buttons on your calculator. And we'll look at a tan ratio and how to find angles.